Hey YouTubers, I'm Professor Alan Duffy, and on Space News today I'm going to talk about how Antarctica is rebounding because its mantle is more similar to a bowl of honey than it is a bowl of water. And we're also going to talk about a very unfortunate Japanese exploding rocket.
When you think of Antarctica, what springs to mind? A cold, hard land, icy and rugged?
Well, a new study suggests that while it may be cold and rugged, parts of the southern continent could actually be described as squishy. So to explain, astronomer Professor Alan Duffy from Swinburne University joins us. Alan, I'd not often use the word squishy when thinking of Antarctica.
No, and I guess it's a question of timescales, but this frozen wilderness is actually rebounding. Antarctica is rising up at the rate, actually about that your fingernails grow, but about 40 millimeters per year. It's the fastest rate of growth anywhere on the Earth. And unfortunately, it's because we have the melting of the Antarctic ice sheets. But that melting is taking away the weight of that ice on the land, and the land is rebounding. And it's doing so at this fast, incredibly fast rate because the mantle under Antarctica happens to be a bit squishy or less viscous.
Oh, right. And what are the long-term consequences?
Well, they're actually quite positive if it's fluid enough. And I'm going to just do a quick little demo here to explain what I mean by viscosity and the different states of the mantle. So this is a very low viscosity liquid. We call it water.
Yes.
And with this bouncy ball, say this is the crust, this is the Antarctic sheet.
Yeah.
And my hand is the ice. As the ice disappears, it rebounds. Right?
Yes.
I don't think anyone would be too surprised by that result.
No.
So that's the rebounding of the crust. Now, it's not like water, the mantle. It's a lot more viscous. And as we'll see here,
that's honey. This
is now honey. But if I let that go, it's got a very, very slow growth. And then
oh, there it goes.
There it goes. Yeah. And it's rebounding.
Right.
It's not like honey. This is about 10,000 times as viscous.
Yes.
10,000 centipoise for those who love those units. This is very viscous. This is peanut butter.
Crunchy or smooth?
Smooth. I mean, I eat crunchy, but for scientific purposes, it has to be smooth. And as we can see, this is 250,000 times as viscous as the water, and not a lot's happening.
No.
So the less viscous, the faster the rebound, right?
Yes.
And the sheet of Antarctica is rebounding that quickly that we know it's far less viscous, less thick. It's more like honey than it is peanut butter in this demo. However, just to put it in context, it is still molten rock. It is 1 trillion times as viscous as the peanut butter is to the water. So it's squishy, but it's still rock. So
no, it's not really squishy, actually.
It's still rebounding, and it's rebounding at a rate that's fast enough. And here's the good news, that the land might actually rebound quickly enough to catch the ice sheet of Antarctica, the western shelf in particular, and actually stop it sliding off into the ocean. And that would actually reduce the rapidity of the melt of the ice sheet. So we could have a very strange silver lining to this global warming.
When do we get to know if that's going to happen?
In the next decade, we'll know.
Okay.
Yeah, and we've got our fingers crossed because it means that sea level rises could be closer to 1 meter by 2100 than the 3 meters that it could be, which is a very bad news.
I have a very unscientific question, Alan. How do you remove those balls from the peanut butter and the honey?
Nate, can you give me a hand?
It's Nate's job, is it?
That's Nate's hand. I don't think I told him about that, but yeah.
How many jars of peanut butter is that?
This is just one giant jumbo pack, and I won't mention for where I got it, but all good. All good.
Well, actually, I've got some toast here I need some peanut butter for. I can probably scrape around the edge of the ball. That's still...
It's reasonably hygienic. Yeah, sure, go with that.
And also, which PhD student actually measured the viscosity of peanut butter versus water?
Do you know, that's a great question. I was actually fascinated to discover the amount of work that someone had done. I read this paper, and it shows the different types of ingredients of peanut butter and consistencies. There is literally a 12-page paper on the different viscosities of peanut. For me, I find that fascinating.
All right, I think that we've given that a good little go around because we showed earlier some amazing pictures from the weekend of a rocket that failed to launch, Alan. What happened there?
So this is Momo 2, launched by Interstellar Technologies in Japan, a startup. its big plan was to build off-the-shelf component, take off-the-shelf components, make it cheaper, and allow you to get to space much more easily and quickly and cheaply. And obviously, it spectacularly failed. We actually don't know what has occurred. I mean, clearly, I suspect the fuel was interrupted just enough to drop the pressure on this, but it was enough to cause it to, of course, crash. In the devastation it
unmanned,
unleashed,
we should say.
It's uncrewed. It didn't even have a satellite on board. It was still a tech demo, but a bit embarrassing because this is now the second rocket fail by this young startup, and it's not clear how many more they can actually afford cheap components or not.